I clicked it after I made that joke, so we're all good.
Wait, it's on?
I don't know.
I gotta say, what the
You never
No,
do.
you never heard the voice.
You just have more time.
It gets
All right, it's gonna get a little cold in the next couple days, so better do some warm up problems.
I know. Okay. Are we finished with linear and exponential?
Yes, decide if it's linear or exponential.
Minus one.
Wait, no.
Minus
No, you divide it.
minus
Our
4.
one is.
Minus 2 minus 1.
Oh, just give it away there, Elia.
Oh. Well, actually, tell you what I did.
Oh, no.
I mean that it would be linear, but it's.
I was listening.
Anyways.
No, that's what I got wrong. It's not.
All right. Notice the x's are changing by 1 each time, going up by 1. What's happening to the y's? You need to think 2 different ways. 1, linear. Is it changing by a constant amount each time? Or 2, exponential. Is it changing by a factor each time? Well, if I start by linear, I would say it goes down 4, then down 2. If it was linear, it would go down 4, down 4, down 4, down 4. Not linear. Agree? So next I say, is it going down by a factor? And a factor means multiply. So am I multiplying by a number each time, the same number each time? Multiply by what to go from 8 to 4? I know you're going to say divide by 2, but it's a factor. A factor means multiply. 1/2, right? Times 1/2. Times 1/2. Times 1/2. That's going to be important for us today. Not to think of it as division, but multiplication of a fraction. Let me say it again. Multiplying by a fraction. Factor. Right? Multiplication. So, since there is a common factor, this one is exponential. How about this one? First of all, the x is changed by add 4, add 4, add 4. Good. Let's check the y's. Minus 1, minus 1, minus 1. Therefore, it is linear. Linear.
Linear.
All right. Questions on the homework? I don't have the homework up here. Do you guys have some questions that you'd like to go over? I apologize. I don't have the homework problems up there. They do it old school. Doesn't he have Matthew pass out the guided notes?
And that's Brady's job. I collect the.
He collects the homework.
Yeah. I need to get paid for
Little
this.
job. We need like a little job.
You're getting paid with knowledge.
Oh,
Oh yeah, did you hear that? Wait, was that conversation yesterday?
I'm sorry.
That's very disrespectful.
All right, what questions from the homework would you guys like to discuss after checking the answers?
21.
21?
Next to it.
Uh-oh. Section was that? 6
It's page 318.
Thank you.
21 on.
318. You said 21?
Yeah. Seems really nice.
Directions. Graph the function, compare the graph of the graph to the graph of the parent function. Identify the y-intercepts and asymptotes of the graphs. Find the domain and range of that. That's just too much work. Let's just graph it. What values do we typically use? Very good. All right, let's plug in -2. And you guys can use calculators for this, okay?
This is a lot of numbers.
That's 1 over 128, isn't it?
It's a lot.
Oh, I did it.
That's 1 over 128. Yes.
I rounded.
Right. So what did you get?
0.01. Probably should.
0.08.
Yeah.
Wait, -2 equals.
I got 0.008.
Yeah.
That's what I got. Well, I got 0.0078.
Yeah,
which is
yeah.
Obviously.
Yeah, that's okay. I'll tell you what. That decimal is so small. What's it close to?
Yeah.
0, right? So at -2, then I'm going to do this correctly today. I'll go by 2s, so it makes it more interesting.
-2.
All right, at -2, the y value is 0.008. That is a very small y value, close to 0. Let's plug in -1.
It's 0.0.
It's 1/16, so
What? It's like 0.6.
0.0625.
So it's close to 0, yeah.
0.0625. All right, so add -1. It's still a pretty small decimal. It's going to be tough to show the difference there, isn't it?
Yeah.
How about at 0? 8 to the 0. We don't need a calculator for this one. What's 8 to the 0? What's 8 to the 0?
0.
1 times a half. So 0.5.
0.5.
At 0, let's go by 1, 2. So at 0, we're at a half. At 1, what's 8 to the first power? 8 to the first power? 8 times 1/2? 4. So at 1,
Oh, that's a big change.
that is a big change. It's almost exponential. All right. At 2, 8 squared is 64. What's half of 64? 32. Off the charts. Off the hook.
Get it? Because it's like off the chart.
Really?
That was like 26.
Thank you. I do what I can for you guys.
Because whenever I was the there, up there.
What's up there?
Somewhere.
What's
A point.
I need to.
what's
You
a
be more
two?
specific.
I was. All right. Does that make sense? Now, let's graph it. Does this graph exist over here?
Yes.
Yeah, we just didn't plot points there, right? What is it getting close to as x goes to the left? It's even getting closer to 0, isn't it?
Yeah.
Look, as x goes really negative, aren't these dots getting closer and closer and closer to this x-axis? Let's call it an
Exponent.
sounds like a bad word.
Oh.
Asymptote. Yep. Asymptote. Asymptote. Careful. Missed it. Shh. You have to make sound effects.
You missed it, yeah.
All right. That is what the graph looks like. Exponential. All right. Now there's some other questions on this, like what's the domain? What's the range? What's the domain? Can I plug in any number for x?
Yep.
Or are there going to be some problems with some of the, if I plug in a value for x, am I not going to get an output? Any value, I'm going to get an output, aren't I? It's just really far to the right, they're going to get huge. Do you agree? Really far to the left, they're going to get really close to 0.
Will they ever hit 0?
No. Just like Braden. Never hit the door. Okay.
He did.
What's the range? Range is what y values are going to come out of this thing. Can I ever get a negative y value in here? No. Am I ever going to get a y value of 0? No. My range, y, or f of x, is greater than 0. Do you agree that the x-axis is y equals 0? Yes?
Yes.
That's like the water level. Am I ever going to hit the water? Do you understand what I'm saying?
Probably.
This is the water line.
Oh,
Okay, pretend that's the water. Is this graph going to ever hit the water? Is it ever going to hit 0?
the bird's not gonna
No, but it's greater than 0.
bird's not gonna
Okay? Does that make sense for range? Cool. Any other homework questions you'd like to discuss?
11.
Oh, I closed the book. 318, page 318. E11. Evaluate the function for the given value of x.
I got 2.
No, plug in 2 for x. What's 3 to the second power?
Oh. 9.
9. You did 3. You did 3 times 2. Exponent means multiply the base 2 times. 3 times 3. Other homework questions? Excellent. Yes.
13.
Plug in 2. What's 5 squared?
100.
5 times 5.
25.
5 squared is 5 times 5, right?
Wait, why is it so negative?
Hold on. I'm not there yet, Elia.
I'm sorry, it's negative 4. I didn't realize it.
5 times 5.
Hey, Lion?
25.
And then there's a negative 4 out front being multiplied. What's 25 times negative 4? 25 times negative 4.
Negative.
What's 4 quarters?
Negative 4 quarters.
What's 4 quarters? A hundo
Yeah.
times a negative.
Negative 100.
Negative a hundo.
This is like
Got it?
the only way they can understand.
Got to speak in their language.
Yeah.
That's too funny.
Theirs.
The hip lingo.
The boy lingo.
Are you Sony or Xbox player?
Depends when you ask me.
Because Sony might
What
be
about right
getting
now?
sued.
For what?
I guess they're like putting like more money on their store than there was.
Mhm.
The
You
actual
don't need
piece.
this department to get sidetracked. You got me.
Yeah, guys. It's actually really selling.
At 9:40.
All right, exponential growth and decay. Exponential growth and decay. You're going to come across this quite a bit in science classes. Have you guys done this in science classes before? Yeah, you can collect those, can't you? Have you done exponential growth and decay in science before?
I think so. I've heard the word exponential.
I've heard decay before.
Have you done radioactive decay?
Yes.
Yes.
Last 8th grade.
Oh yeah.
Polonium 222 or what's the other one that's pretty? Radon 222.
Let's get cracking.
Send Russ.
I don't know anything.
All right.
I don't care.
All right, exponential growth occurs when a quantity increases by the same rate, factor, r in each period of time. When this happens, the value of the quantity at any given time can be calculated as a function of the rate and the original amount. That's a lot of words. Let's just look at the example here. Okay, here's the thing. An exponential growth function has the form y equals a times b to the x. Here's what you need to understand. This is confusing for students, okay? The reason why it's exponential is where the x is. We know that. That is slope-intercept form, isn't it?
Yes.
Y equals m times x plus b. By nature, if you increase by 1, the y value is going to go up by m. Increase by 1, up by m. A constant rate of change, a slope. This one has a slope. Do you understand? It has a constant slope. What's the slope? M. Maybe it's 4, maybe it's -2. Look at this graph. Does this graph have a constant slope? No. Look at it. What's the slope close to over here? 0. Steep. Really steep. Did it stay the same? No, it changed from 0 to really steep. Why? I'm glad you asked. It's where the x is. It's where the x is. So as x increases on this one, try to listen, guys. This is trying to help you out. It's all about where the x is, okay? If the x is in the exponent, not down here, if x is in the exponent, let's make an example. B is 3. Well, then when you go to plug in values to this graph, you're going to have 3 to the 1, 3 to the 2, 3 to the 3. X is changing, isn't it? 3 is staying the same. X is changing. 3 to the 4, 3 to the 5. And don't we usually graph like on windows of like -10 to +10? Type in 3 to the 10th for me. 3 to the 10th power.
59,409.
59,000. I don't care what the rest is. That's a big number. Look up here for a second. When I go over to 10, if I'm doing 3 to the x, 3 to the 1, 3, 3 to the 2, 9. I'm already almost off the paper. 3 to the 3rd, 27. 3 to the 4th, 81. 3 to the 5th, I think 283. No, what's 3 to the 5th? 243? All right. 3 to the 6th.
729.
Man, we're only up to 6, and we've already huge. So what is going on here? Okay, all eyes up here for a second. Repeated multiplication versus repeated addition. Repeated addition is linear. Rise, run, rise, run, rise. Repeated multiplication is exponential. That's why this x being up there makes this grow way faster. Do you understand that? It's where the x is, okay? So this is the general form of an exponential function, just like this is the general form of a linear function, all right? What are a and b? They're numbers. They're numbers, like we saw last night, all right? Now, you can write the growth factor b as the sum of 1 and the rate of growth r. Okay, that's kind of confusing. We'll talk about that later. But rate of growth, okay? Do you want to hear how this is applied? Do you guys care about that or do you not care?
I care.
Okay.
I care.
Everything has a rate of growth in exponential. Like if it's an exponential function, it will have a rate of growth. We talked about the pandemic yesterday. Early on in the pandemic, what were they trying to model? They were trying to model how transmissible the virus was. Do you remember that? Have you heard that? How transmissible it is. Okay? COVID-19 versus the Delta variant versus the Omicron variant, right? How transmissible is it? So is one person passing it to one person? Is one person passing it to two people? Is one person passing it to three people? On average, what's happening? How transmissible? Okay, that's your rate of growth. That has to do with the rate of growth. Okay, is it a 1-to-1? Is it a 1-to-2? Is it a 1-to-3? Is it a 1-to-4? Because then what happens is, guess what happens if I give it to one person and it's a rate of growth of 1-to-4? They're gonna pass it to. You go back. If I pass it to 4 people, what are they gonna do? Possibly.
It's just safe.
Hold on. One person has it. Keep track for me. One person has it. Now, 5 had it, right? And then
5/4. This whole class is gone.
class all has it now. 1 transmission to 4, and then when they transmit it, everyone in the room has it now. Do you see what I'm saying?
Mm-hmm.
Now, what about a 1-to-2? Ready? 1, go up to 3. Okay, after 2 transmissions, only this group has it right now. Do you see the difference? That rate is has a huge role in this. So guess what happened? They said flatten the curve. Guess what they meant? Watch. Do they want this to happen? No, hospitals are in trouble if this many people have it. Cause this to happen. Okay? Decrease the rate of transmission. How? Social distancing, mask, whatever. I don't want to get into politics of it, but all of those things we're trying to reduce the rate of growth of the virus. Does that make any sense to you? Okay, this is the application of this exponential growth and decay. This also applies to good things like money. Okay, if you invest your money and you have the stock market on average over the last 100 years has had a rate of return close to 10%. 10% rate of growth, 10% on average. So if you invest long enough, you're hoping that rate of growth is going to be 10%, and you could find out how much you're going to have in your bank account if you have an initial amount that you invest, and then you have a rate of growth. And there's also formulas that take into account if you keep contributing like $50 a month, $100 a month to that, you'll see your account grow pretty quickly. Make sense? So this applies to a lot of different areas. All right, the original value of a painting. So let's keep this in mind as we go. I'm going to actually bring this over for us. You're going to want this formula nearby as you're doing problems. All right, the original value of a painting is $9,000. Where do you think that should go? Go in for what letter?
Initial amount.
Yeah. Is this on your paper? Okay.
Yeah.
Y equals 9,000. Initial amount, original value, initial amount. And the value increases by 7% each year. Where do you think that's going to go? Yeah, 1 plus r to the x. So I bet you guys would figure out the only thing that's going to change from problem to problem is what the initial amount is and what the rate of growth is. Do you agree? Yeah. Those are the changing quantities. All right. What is the rate of growth if it's 7% in decimal form? What's 7% in decimal form?
Wait, 7?
0.7 or 0.07? What is the word? Okay, when we say it all the time, you guys never stop and think about it. If I say 7%, if I'm a 7% half court shot maker in basketball, if I shoot 100 shots, I'm gonna make. Okay, whoa.
50.
What is the word percent mean? Percent. What does the word cent mean? Century. Cent. Cents and money. Per 100, isn't it? Isn't it per 100? Isn't 7% 7 per 100? If you got a 7% on a quiz, hey, don't do that. 7 out of 100. 7 hundredths. 7 tenths? No. 7 hundredths place. Do you agree? 0.07. Write an exponential growth function to model this situation, then find the painting's value in 15 years. Okay. What should we plug in for x? 15. Y equals 9,000 times 1. What is 1 plus 0.07? 1.07 to the x, so to the 15th. So in your calculator, you're going to type in 1.07 to the 15th, and then multiply that times 9,000. Is everybody typing this in along with us? Do you guys know how to enter these exponentials in? Are you getting $24,831.28?
Yeah.
Are you guys getting that? Double check your calculator work. Make sure you guys are getting that. Is that a pretty good investment in 15 years? To go from a value of $9,000 to $24,831? Yeah. 7% per year. Okay. I don't know. My goal as a teacher is to kind of teach you the application of this. That's kind of why it's cool. Just like the virus spread, the money is spreading. Okay. After the first year, it's gained 7%. Okay, so now it's not $9,000. Now it's $9,630. And then after 2 years, $9,630 gains 7%. And then that amount gains 7. Do you see how that 7% gets compounded on a bigger number each time? It's spreading, okay, in the same way. All right, exponential decay works in the opposite direction. It's not growing, it's getting smaller. All right. So instead of 1 plus r on the inside, it's going to be 1 minus r on the inside. And that r is the rate of decay, and the inside is the decay factor. Now, don't read this. I'm going to try to make it a lot easier words for you, okay? What's the difference between 1 plus r and 1 minus r? Well, what is r going to be as a decimal? Somewhere between more than 0 but less than 1, right? As a percent, 0.99, 0.01, 0.07. If I add that number, I'm going to get like 1.07 or 1.8. That would make it grow. What happens if I subtract 1 minus 0.3? What's 1 minus 0.3? 0.7. What happens when you multiply by 0.7? Because isn't this repeated multiplying of 0.7? 0.7 to the 1, 0.7 to the 2, 0.7 to the 3. What happens when you do 7/10 of something? Does it get bigger or smaller? What if you have $10? What's 7/10 of $10? $7. Did your amount go from 10 to 7? Did it get smaller or bigger? Smaller. Guess what? Take your $7, take 7/10 of it. Did it get bigger or smaller? Smaller again. So if you multiply by a decimal less than 1, it's going to keep getting smaller. That's why it's decaying. All right? All right, let's do an example here. The population of a town. So we have y equals a times 1 minus r to the x. Because the population is decaying at a rate of 3% per year. So what's our r in this problem? 3% as a decimal, Matthew.
Would be 0.03.
0.03, very good. R is 0.03. In 2020, pretend this is 2020, okay? Pretend this is the year 2020. There were 1,700 people. So what's A? What's the initial amount of people? Good. We have enough information to write our equation. 1,700 times 1 minus 0.03 to the x. I prefer to write it 1,700 times, what is 1 minus 0.03? 0.97, very good. 0.97 to the x. All right, write an exponential decay function. Got it. Find the population in 2032. 2032. What's the x value in 2032? How many years have passed? 12 years, right? Because 2020 is like 0, right? It's now.
Yeah.
Now. All right. 12 years have passed. So plug in x equals 12. Are you getting a population of 1,179.53?
Yes.
And then you'd have to be told whether we're going to round to the nearest person. Maybe we have half of a person. I don't know. Hey, they're doing whatever they want to do, okay? 1,179.5 people. Is that a reasonable answer? How do you check that to see if it's reasonable? The amount you end up with should be blank compared to the amount of people you started with. Less, because the amount of people are decreasing, right? Make sense? Logan. You good? All right, determine whether the function shows exponential growth, exponential decay, or neither. Well, first of all, exponential functions have a constant, not constant change, that would be linear. Constant rate of change. You're being kind of picky, Mr. Westfall. I am, okay? If it had a constant change, it would be linear. Constant rate of change, exponential. So first of all, check. X is going up by 1. Good. How do we get from 270 to 90? It's always multiply. Multiply by
0.3.
Yeah, let's write it as a fraction. Yeah, so change that. So do you guys know how to do that in your calculator?
Yeah, second PRV.
Yeah, so do 90. It's always new divided by old. So 90 divided by 270. And then second PRB, it'll make it 1/3. 1/3. And then is 30 a third of 90? A third. Is 10 a third of 30? A third. So is it exponential? Yes or no? Yes, exponential. Next question. Growth or decay?
Okay.
Growth.
DK.
As x goes from 0 to 1 to 2 to 3, are the y's going, are they growing
They're going down.
or are they decaying?
They're decaying.
They're decaying. Look, I had 270, now I have 90, now I have 30, now I have 10.
That's convenient.
Decay. Let it be. Is there a constant factor? Let's see. 5 to 10 is times 2. 10 to 20 is times. Ooh, it's exponential. Growth or decay?
Growth.
You good? Awesome.
It's like you.
All right. Now, compounding interest is kind of like what I was talking about with money. Not kind of. It is what I was talking about with money. All right. There's only a little bit of a change here. The thing is, you need to add on the amount that you got in interest. Do you guys know what interest is? Okay. If I let you borrow $100 and I say, yeah, you can borrow $100, but I'm going to charge you 2% interest. Well, when you pay me back, you're going to have to pay me back $102, not just $100, right? But then what if you don't pay it back? And I say, I'm going to charge you another 2% interest. It's not 102 anymore. Now it's 102 times 2% more. Okay, that's growing. That has to be compounded each year for money. So what has to happen is you have to multiply the number of times you compounded times the time in years. All right. So this is the equation there. So n goes in here. So when you have your rate that we've already worked with, you divide it by the number of times it's compounded per year. Annually means once per year. Quarterly means 4 times per year. Monthly means 12 times per year. All right. So last problem for today. Write a compound interest function to model each situation. So we need the y equals p, capital P, which is what you start with, the principal. You're going to need your notes for this, by the way. 1 plus r over n to the n times t. I'm going to run out of time. But where would the 1200 go? P. Invest at a rate of 2%. So 0.02 goes in for R. Compounded quarterly. N equals, go back to here, quarterly. Quarterly means N equals 4. 4 times per year. N equals 4, and then we're going to plug in 3 for the time. Sorry, I had to rush that. All right, your homework for tonight is a Big Ideas Math assignment online. Let me say it again. Go to Canvas, click the BIM app tool, and check for assignments. It's in there. That'll help us check your answers and see how you're doing on those. Make sense? May your day grow exponentially better. From here.
I just had a.
Thank you. Thunder was Thursday.
I just had a mic.